During testing, crew members on the ground will monitor the status of the spacecraft's return to Earth, but they will temporarily lose the data connection because of the plasma's extremely high temperatures. The onboard jets continue to maintain the proper orientation for re-entry into the Earth's atmosphere, while the heat shield, which is the largest of its kind ever constructed, protects the rest of the vehicle. Finally, Orion will deploy parachutes in stages to gradually reduce the speed until it reaches a safe landing.
Just look at this cone-shaped thing come out. This is what they do every time. They litter all over in the ocean and everything. But anyway, so the thing naturally does not want to fall the way that they say that it's going to fall. It is going to try to turn over, and they've attached the parachute basically to the wrong side. And this is exactly what I'm talking about. It's like an arrowhead dropping, and the arrow wants to turn over. See, it's rolling, it wants to turn, and it's rolling, it's got some momentum, but you can tell it's either going to spin out of control or it would stabilize like sideways or pointing the other way, because this one's kind of flat, but it's just, you know, obviously this such a disaster here. Now when I found this video, it led me into the next one that I'm going to make, which will blow your mind. At least it blew my mind, because I could tell it was real NASA footage. I mean, some of it they've doctored up and made fake and altered it and everything, but man, I hope nobody was in that thing. The capsules are more cone shaped. I'll show you how kids know how cone drops.
That I've done with middle school students. It can even be done with elementary school students. Well, we saw that flight wasn't very stable. So what I'd like to do is I'd like to change this slightly. So let's try that. Okay, so now we see the cone is a lot more stable than just the flat circle that was falling. So here's the investigation. What can we do to the cone? What kind of changes could we make that would either make it fall faster or slower? That would be a problem that I would present to my students, and then I would have them get into groups of 2 or 3, and they can brainstorm about how they would go about testing various variables. What kind of things could we change? What kind of things could we change? Well, we might look at changing the weight of the cone.
Cones can be made heavier by adding something small to it or simply stacking more than one together.
We might change the angle of the cone.
Smaller angles to bigger ones can be measured fairly easily.
To do that, I've actually made these cards up, which we use. There's 30 degrees, and 45 degrees, 60 degrees, 75, 105 degrees, 120, 135. That's probably about as wide as we can make it. Anything wider than that, it starts becoming unstable.
Unstable like this. Middle school science class, an average middle school science class student knows better than this, than what NASA does.